S represents displacement in meters and T represents time in seconds. The velocity v meter per second of a moving body is given by v is equal to 40 minus 80, where a is a non-zero constant. First part, if s is 100 when t is equal to 0, find an expression for s in terms of a and t. Expression means it's an indefinite integration. Why integration? Because you already have velocity and you are supposed to find out the displacement. So it's a reverse process. I repeat again, if you know s and you want to find out v, you do ds by dt. That is derivative. And if you know v and you want to find out s, you do integration of v dt. That gives you s. So here in this case, I know velocity, I want to find out the displacement, so I am using an indefinite integration because I want expression. So let's start with the first part. I will write down directly s is equal to integration of v dt. So in this case, your v is 40 minus 80 dt. So your s is equal to, separate this, 40 dt minus 80 dt. So s is equal to 40 dt is basically integration of constant is constant into x, but now we are using a t variable, so 40 times t. A is a constant, integration of t raised to 1 is basically t square over 2. It's an indefinite integration, so you will use plus c. Number this equation, say equation number 1. To find out c, they have given initial condition s is 100 and t is 0. So we will substitute s is 100, t is 0, so 40 times 0 minus a into 0 square over 2 plus c. So 100 is equal to, this is 0, this is also 0 plus c, so c is equal to 100. Rewrite that in this equation. So your equation is equal to 40 times t minus a t square over 2 plus 100. Second part, when s is 0, t is 0, write down an expression, again indefinite integration for s in terms of t. So we already have this s equation because we are taking the same integration, but only your s and t becomes initial values. Initial value means what? T is equal to 0, s is equal to 0. So we will substitute s is equal to 0 and t is equal to 0 in equation number 1. So that becomes s is equal to 40 times t minus a t square over 2 plus c. Now it becomes 0 is equal to 0 minus 0 plus c. So c is also becomes 0. So their final equation is s is equal to 40 times t minus a t square over 2. Second part. Trains approaching a station start to slow down when they pass a point P. As a train slows down, the velocity is given by v is equal to 40 minus 80, where t is equal to 0 at P. The station is 500 meter from P. A train M slows down so that it comes to stop at the station. Stop means what? Velocity becomes 0. Find the time it takes train M to come to stop, giving your answer in terms of A. Stop means velocity is equal to 0. So in this case, 40 minus 80 is equal to 0. So 40 is equal to 80. They want time. in terms of A. So T, keep it over here, divide both sides by A. So T is equal to 40 over A seconds. Second part, hence show that A is equal to 8 over 5. We already got T value is 40 over A. Now we will substitute this value in your S equation. In your S equation, that means we will use S is equal to 40T minus 80 square over 2. So I'm using S is equal to 40 times T minus A times T square over 2. So S is equal to 40 into T value is 40 over A minus A over 2. T value is 40 over A, so 40 square over A square. Simplify this. 40 times 40 is 1600 over A. 1A get cancelled. 40 square is again 1600 over 2A. Make the base same and solve for this. So this becomes 1600 over A minus 800 over A. Now bases are same. 1600 base are same, so 1600 minus 800 is basically 800. Now they have given 500. The station is 500 from P. That means S is equal to 500. So 500 is equal to 800 over A. So A is equal to 800 over 500, which is 8 over 5. Last part. For a different train M, this was a different train M, now this is N. The value of A is 4. Show that this train will stop before it reaches the station. A is given as 4, so we will rewrite this velocity equation 40 minus 80 as V is equal to 40 minus 4t, because A is 4. Again the train stops, means velocity is equal to 0. So 40 minus 4t is equal to 0. So 40 is equal to 4t. So t is equal to 40 over 4, which is 10. Now we have to show that it stops before it reaches the station. The station is 500 meter from P. So meter stands for displacement. So we will again use the displacement equation and we will show that. So S is equal to 40 times T minus A times T square over 2. So 40 will remain as it is. T value is we found out as 10 minus A is given as 4 into T value is 10 square over 2. 40 into 10 is basically 400. 100 into 4 is 400 over 2. So 400 minus 200, which is basically 200 meter. So if your A value is 4, the train stops at 200, whereas the station is 500. 200 meter is less than 500. This means train stops before the station.